Hi, my name is Alison Buck. Today we'll be learning in two parts. The first part will be Hemiacetals, and I'll be going over that one with you, and then Acetals, and my friend Mayra will be doing that later on. First, I'm going to show you an illustration I have made using candy pieces. At the bottom center of the page, I have made a key. Yellow Skittles will be oxygen, green Skittles will be carbon, orange Skittles will be hydrogen, red Skittles will be an R group, and red Twizzlers are the bonds. On the far left side of the page, I have drawn two beta symbols. One's positive and one is negative, which means this is a polar bond. There's a double bond connected from a carbon to an oxygen group. And then added to that will be an alcohol group. So the yellow Skittle is going to be the oxygen, and then on the top there's a hydrogen, and to the right there's an R group. And when you add these two together, they react to form a hemiacetal on the right side. The green one is the carbon. The top has an oxygen, and the double bond is broken from the first molecule to form an oxygen and hydrogen at the top, which is a hydroxyl group. And then to the right of the green carbon on the hemiacetal, the yellow is another oxygen from the alcohol group that was put over there, and then you add the R group that was originally on the alcohol group next to it. At the bottom of the hemiacetal, you will either have a hydrogen or an R group depending on if it's a ketone or an aldehyde. Now that I have showed you what the general formation of a hemiacetal looks like, I have prepared another candy illustration showing the general form of a hemiacetal by itself. The green Skittle in the middle represents a carbon, and the four red Twizzlers branching from it are showing the single bond formations. To the left of the green carbon is an R group shown by the red Skittle. Above the carbon, you will see the yellow oxygen and the orange hydrogen, which create the hydroxyl group. To the right of the carbon, there are another yellow oxygen, and attached to that, there is a red Skittle representing the R group. Lastly, at the bottom of the structure, there will either be a red Skittle representing an R group or an orange representing a hydrogen. If the hemiacetal is formed by a ketone, then the bottom will have a red Skittle representing the R group. And if the hemiacetal was made from an aldehyde, it will have the orange Skittle representing the hydrogen. The example being illustrated shows an aldehyde, butanol, reacting with methanol to form a product of a hemiacetal and ethanol. Notice how in this reaction, the red Skittles again represent the R groups. The double bond connected to the oxygen is also broken to form on the right side an OH or hydroxyl group above the green carbon in the middle of the hemiacetal. Also know that there is an orange Skittle below the green carbon because it represents a hydrogen, since this reaction is an aldehyde reaction. This last example consists of a ketone reacting with an alcohol to form a product of a hemiacetal. Notice how the double bond on the ketone on the left-hand side is in the middle of the molecule, showing that it is indeed a ketone. And from there, the double bond is broken to again form the OH or hydroxyl group on the hemiacetal at the top. The alcohol group is added onto the oxygen, the yellow Skittle, on the right side of the hemiacetal. One example of a hemiacetal you can find in everyday life is glucose. About 99% of glucose exists in cyclic hemiacetal form and 1% in open form. Glucose's hemiacetal form is C6H12O6. It has an aldehyde group and 5 hydroxyl groups in its Fischer projection. Glucose is commonly called sugar. It is an important energy source that is needed by all cells and organs in our bodies. It comes from foods we eat, such as fruit, breads, pastas, hard candies, and many more. This ends part 1 of our video discussing hemiacetals.
Hi, my name is Mayra. This is part 2 of our video. I will be discussing about the formation of acetals. First, I would like to show you in this illustration the general form of an acetal formation. You start with one carbon with 4 groups branching from it. On the left side, there will be a R group. Right above the carbon will be an oxygen and a R group attached to it, rather than having a hydrogen and hydroxyl group like in hemiacetal. To the right of this carbon, there is an oxygen and an R group, and below we have either an R group or a hydrogen. You will have a R group and the reactant is a ketone, and you will have a hydrogen if your reaction is an aldehyde. In the bottom right, I made a key explaining what each symbol stands for. A acetal formation is the presence of a small amount of acid catalyst. Hemiacetals are converted to acetals. The origin of the acetal comes from the hemiacetal form. You add a R group, the oxygen to the carbon, instead of a hydrogen, making it no longer a hydroxyl group. Acetals are geminal derivatives of aldehydes or ketones formed by reactions with two equivalents of an alcohol and elimination of water. Ketones derivatives of this kind were once called ketols, but modern usage has dropped that term. It is important to note that the hemiacetal is formed as an intermediate during the formation of an acetal. This is a furanose ketone reacting two alcohol groups with H3O added, producing acetal because it splits the double bond on the furanose molecule and water is removed. The reaction is also reversible, shown below. This is a chemical formula of fructose. C6H12O6. This is an illustration of a Fischer projection of a D-stereoisomer fructose. It has 4 hydroxyl groups and is a ketone because the double bond from the carbon to the oxygen is not at the end. Fructose is a simple sugar or a monosaccharide typically found in fruit. Natural rich fructose includes honey and fruit juices. This molecule is a product of an aldehyde and alcohol reacting. There is one methyl group under the second carbon. A R group replaces the hydroxyl group and the H2O is taken out of the reaction. This is a reaction of a ketone and alcohol. They produce a product of an acetal. Notice that the group on top of the carbon is an OR group and the group below is an R group because this is a ketone reaction.
Thanks for watching!